All right. So we had worked with complex numbers. And we are ready to find the discriminant. This is another thing that you might want to consider putting on your final exam review cheat sheet. The discriminant this is b squared minus 4ac. This is the part that goes underneath the square root sign of the quadratic formula. So if you write the quadratic formula down, you technically have this, but that doesn't mean that you know exactly how to use those pieces. So discriminant is b squared minus 4ac. If you do this and it comes out negative, that means 2 complex roots. If you do this and it comes out to be positive, that means 2 real roots. And if you calculate the discriminant and it comes out to be 0, that means 1 real root. That means the vertex is the only thing that touches the x-axis. All right. So the first thing you need to pay attention to is we cannot identify A, B, and C until it is set equal to 0. Then you can ID A, B, and C. So what do I need to do to this to get it equal to 0? Subtract 10 from both sides. X squared plus 2x equals 10. So I'm going to minus 10 from both sides. That cannot combine with any of the other pieces that I've got here. So x squared plus 2x minus 10 equals 0. Now I can identify A, B, and C. What number, because remember, when I plug into the discriminant, we don't put any x's in, only numbers. What number would I use for A? 1. So here's A. What number would I use for B? 2. And what number would I use for C? Negative 10. All right, so let's substitute in and see what we get. B squared. So I'm going to take 2 and I'm going to square it. Minus 4 times A. We're putting in 1 in the place of A. Times C. And we're putting negative 10 in the place of C. What is 2 squared? 2 times itself. 4. So I have 4 minus, what is 4 times 1 times negative 10? 4 times 1 times negative 10. Negative 40. So I have 4 minus, because I'm bringing this minus sign down from right here, 4 minus negative 40. So that turns into 4 plus 40, which gives me my discriminant, which is what? 44. What kind of a number did we get? Positive. So that means 2 real roots. All right, let's try the exact same thing on number 20. What do I need to do with this first? Set it equal to 0. How do I set this equal to 0? Subtract x squared from both sides. So I have x squared equals 2x minus 4. I'm going to subtract x squared from both sides. Can that combine with anything that I already have? Nope. 0 equals negative x squared plus 2x minus 4. What are the values for A, B, and C? -1. A is -1. B is 2 again. And C is -4. All right, so I'm going to substitute in now to b squared minus 4ac. So I have 2 squared minus 4 times, what is our a value again? -1 times c, which is -4. 2 times itself, so I get 4 minus, what is 4 times -1 times -4? 16. So I have 4 minus 16. What is 4 minus 16? -12. What does that mean about my roots then? 2 complex roots. All right. Let's do one more like that one. Do you guys need me to go back? All right. All righty. Let's look at one more like that. And then we'll solve the system. What do I need to do to this first? Set it equal to 0. So I'm going to subtract the 4x from both sides. I have 4x squared plus 1 equals 4x. I'm going to minus 4x from both sides so that I get that 0 that will not combine with any of the other pieces that I have. What is our value for A? 4. For B, -4. And for C, +1. All right, b squared minus 4ac time. Be really careful about this. Make sure anytime you do a substitution, you are putting it inside parentheses, including in your calculator. B is -4, A is +4, and C is +1. -4 squared. What does it mean to square something? Multiply it by itself. So what is -4 times another -4? 16. Minus 4 times 4 times 1. 16. 16 minus 16 gives me 0. So what does that mean? 1 real root. All right. This is the last module 3 question. And then I was hoping that we could go back to the beginning of the packet and work on modules 1 and 2 for the rest of our time together, because it's been a long, long time since we've done module 1 or module 2 work. 4 and 5 is a little bit fresher, so I kind of want to hold off on those until the end because I think they'll go faster. Solving the system. We've got 3 ways we can solve. We could solve by graphing. but if they don't give you a graph, that's probably not a great choice. We can solve by substitution. Or we can solve by elimination. If I'm going to use substitution, I either want the x all by itself or I want the y all by itself in at least one equation. Do I have that? Yes. If I already have an x all by itself or a y all by itself, then that's probably what I want to use. So I'm going to take, we're going to use substitution on this one. I'm going to take x squared and I'm going to put it in the place of this y right here. So this is going to become x squared equals 2x plus 8. So far, so good? Yes. Yes, I do. There you go. Oh. We're using substitution here. I made it take the place of the y. Because we're supposed to solve this, give me synonyms for solutions. Roots, x-intercepts, zeros. Zeros, x-intercepts, roots, solutions. Those are my 4 synonyms. So I'm going to have to use either factoring or quadratic formula to find these x-intercepts, to find these roots. I want my x squared to stay positive, but I have to set this equal to 0, just like we were doing with the discriminant. If I'm going to use quadratic formula, I don't care as much about whether or not my x squared is positive. But if I'm going to try to use factoring, your a value has to be positive if you're going to use factoring. So I'm going to leave the x squared right there. I'm going to subtract 2x from both sides. So that would give me x squared minus 2x equals 8. Have I gotten it equal to 0 yet? What do I still need to do to get it equal to 0? Subtract the 8 from both sides. I know it's a little bit more work to get it equal to 0, but it's worth it because if you have a negative a value and you try to factor it, you won't get the right answer. Right. How do I factor this? What do I need to draw? X in a box. All right, so I have x squared here, I have negative 8 here. So I have to multiply a and c together, 1 times negative 8. So I need 2 numbers that multiply together to give me negative 8. But when I add those same 2 numbers together, I get negative 2. What will do that? Negative 4 and 2. So negative 4x and 2x. These top 2 right here, x squared and negative 4x, what do they have in common? X. What about these bottom 2, 2x and negative 8? What do they have in common? What's the biggest thing that goes into those? Positive or negative 2? Positive 2. We take the sign that's next to it. So x plus 2 is a factor. Now I'm going to go vertically. X squared and 2x. What do they have in common? X. And negative 4x and negative 8. Negative 4. I have 2 factors. How do I find the solutions? Equal them to 0. X plus 2 equals 0. I'm going to come over here for the other one. X minus 4 equals 0. Here I'm going to subtract 2 from both sides. So x is -2, but this is a system. This isn't just one equation. I need to find y now. Use this to find y. So I'm going to go back to my original two equations. I'm going to pick one of them. Are you guys okay if we pick the 2x plus 8? What do I want to put in the place of the x here? I want to put 2 in the place, sorry, -2 in the place of the x. What is 2 times -2? So I have -4 plus 8. What is -4 plus 8? 4. So I have the x, I have the y. My answer gets written down as an ordered pair because this is where these two cross each other. This is where they touch. So in an ordered pair, which part comes first, the x or the y part? The x part. So -2, 4. This is one solution. But how many factors did we find? We had 2 factors. I only used this one over here. Now I need to go and use the other one. So I'm going to add 4 to both sides here. So x equals 4. We're going to use this to find the other y. I can use the exact same linear equation, y equals 2x plus 8. I'm putting 4 in the place of the x. What is 2 times 4? So I have y equals 8 plus 8. Y equals 16. So what's my other solution then? Four 16. Right. So far, so good? All right, snap a picture of it if you need to. Then we're going to flip back to the very beginning of the packet. Very first page. So all the way back to the beginning. These guys right here, we're supposed to identify as linear or non-linear. So they are linear if they are degree 1 or degree 0. If they have radicals, if they have a degree bigger than 1 or not, or smaller than 1 but not 0, then it is not linear. What do you guys think about part A? Is that linear or not linear? Non-linear. Why? Which piece broke it? Square root. This is why it's not linear. What about on part B, linear or non-linear? Non-linear. Which piece is responsible for it being non-linear? Yep, this squared right here. What about C? This one is linear. This one would be a degree 0. It doesn't have any variables at all. This would be a straight horizontal line, just like this. What about D? This one is linear. Each of those variables has degree 1, so it is a first degree polynomial. All right, number 2. Table shows the amount of money remaining in a Starbucks account each month after the purchase without refilling. What do you notice is happening each month? It's decreasing, it's going down. How much is it going down by each month? Yep, minus 25, minus 25, minus 25, all the way across. What does that mean then? What is this person doing? Same order or the same amount. So which question can I answer with this information? I can answer X and Y intercept with just what I've done right there. It is linear. This person is spending $25 each month. Chase, you weren't wrong. Everything that you were answering was correct. I just wanted to know which one of these blanks we could fill in with that. So they're spending, their balance is going down each month. How much did they purchase to begin with? $125. That is the initial amount, the starting amount. Where do you see a starting amount on a graph? Yep. Y-intercept. So that y-intercept is 0, 125. The y-intercept is always going to be the initial amount. Or the starting amount. And they will run out of money in their account when? In the 5th month. So what's my x-intercept then? 50. This is when they're going to run out. All right. If you guys want to snap a picture, now is the time. All right, number 3. Line symmetry, point symmetry, and no symmetry. Line symmetry means I can draw a vertical line somewhere on here and I could fold it in half on that line and the two sides would match up. Point symmetry means that I would put a point down on that graph and I'd twist it halfway so the top would become the bottom would become the top, and it would match up with itself. And no symmetry means neither one of those would be true. On number 3, do we have any kind of symmetry going on here? Line symmetry. If I draw a line right through here and I fold it in half on that line, it would match up with itself. So I have line symmetry here. What about the one in the middle? Do I have line symmetry on that one? No. Is there somewhere that I could put a point down, somewhere that I could put like a push pin and twist it halfway? Nope. So I have no symmetry here. What about the very last one? Line symmetry? Point symmetry. That point would be somewhere right around here. If I put a push pin there and I made the top the bottom and the bottom the top and I spun it around, it would land right on top of itself. So we have point symmetry here. So far, so good? Awesome. All right. Graphing using X and Y intercepts. My x-intercept always has the form of a number here and then a 0 in the place where the y goes. The y-intercept always has the form of a 0 and then a number. So to find my x and y intercepts, I'm going to use what I know about the way the ordered pair has to be written. For the x-intercept, which piece has to be 0? The y part. So I'm going to go to my equation. And for the y, I'm going to put in a 0. What is 3 times 0? 0. So I have 2x plus 0 equals 12. If I minus 0 from both sides, what would that give me on the right? Still 12. What do I need to do to get the x all alone? Divide both sides by 2. So x is 6. So now I know what my x-intercept looks like. The x part of the ordered pair is 6. What does the y part of the ordered pair have to be? Has to be 0, or else it's not an x-intercept. So here's my x-intercept. I'm going to come down here and I'm going to plot that on the x-axis. Then I'm going to do the same kind of thing, but for the y-intercept. On the y-intercept, which part of that ordered pair is always a 0? The x part. So 2, and I'm going to put the x part in as 0. Two times 0 is 0. What happens if I minus 0 from both sides? Nothing changes, stays the same. So I'm going to have 3y equals 12. Divide both sides by 3. And y is what? Y is 4. So my y-intercept is 0, 4. Right here. And now I want to draw that line. How do I draw the line now that I have those 2 points? Yep. Line them up with your ruler, connect the dots. All right. For part B, they don't tell me that I need to use x and y intercepts. So I'm going to put this one into slope intercept form. But what else do you notice about this? It's an inequality. So I'm going to draw my little happy faces. If you found these helpful when we were going through the unit with inequalities, please feel free to copy these onto your cheat sheet. If we have the or equal to under it, it's going to be graphed with a solid line. On a number line, it would get a filled in dot, but on a graph, it just gets a solid line. If it doesn't have the or equal to underneath it, we're going to graph it with a dashed line. If it was a number line problem, we would use an open circle there. What do I need to do to that inequality to get the y all by itself? Subtract 1 from both sides. So that's going to cancel out here. Will it cancel out on the other side? -1 minus 1. Will those cancel? No, I'll get what? -2. Here's my y-intercept. So I'm going to go to -2 on the y-axis, and I'm going to put a point down. So what do I use the 4 for? Rise over run, 4 over 1. That is my slope. So up 4, right 1. Up 4, right 1. Up 4, right 1. Take it backwards as well. Do I use a dashed line or a solid line here? Dashed. Because my inequality did not have that or equal to with it. And then we have to test a point. Does my dashed line go through 0, 0? Does it go through the origin? No, it comes really close to it, but it doesn't go right through it. I like using 0, 0 as my test point. You don't have to use 0, 0. You can use a different ordered pair if you want to, but I recommend using something like 0, 0 or 1, 1 or 10, 10. Something that's easy to work with where the X and the Y are the same. You do not want to pick something that's actually on your line. So if I get back something that's false, then I don't shade the side where 0, 0 is. I have to shade the other side. If I get back something that's true, then I shade the side where 0, 0 is. I'm going to go back to my original inequality. I'm putting a 0 in for X and a 0 in for Y. So my original inequality, I have Y plus 1 is less than 4X minus 1. And now I'm going to replace the X and the Y with zeros. What is 0 plus 1? 1. What is 4 times 0? And 0 minus 1. What is 0 minus 1? Negative 1. This says 1 is less than negative 1. Is that true or false? Is 1 smaller than negative 1? Nope. This right here is false. So do not shade where 0, 0 is. So where do I shade? Do I shade over here? Do I shade this side over here? I shade underneath it. I got something false. I do not want to shade where 0, 0 is. So we're shading this side. We could have done our test with a different number, like I said before. I could have done it with something like, I don't know, 10, 10. Let's see what happens if we test with a different number. So just like I did before, I'm going to put a 10 in the place of the X and a 10 in the place of the Y. So 10 goes in for X, 10 goes in for Y. What is 10 plus 1? 11 is less than, what's 4 times 10? 40 minus 1. What is 40 minus 1? 39. So I have 11 is less than 39. Is that true or is that false? Is 11 smaller than 39? That is true. So we shade where 10, 10 is. Yes. If the open mouth is this way, It is a less than, and if the open mouth is this way, it's a greater than. Yes. Yes, sir. Yes, you may. Right. In our graph right here, did we shade the side of the line where 10, 10 already is? Yep. Chase, here's how I remember it. With your left hand, you make the letter L and it looks like an actual letter L. And if I tip it, that's a less than sign. So left hand L, less than. Took me until senior year of high school to remember the different names for those two. Like I was always just alligator eats the bigger thing. That's how I remembered what was supposed to happen, but I didn't know the names of them. And this finally made sense to me to help me remember it. So, all right, let's go look at number 5. Now's the time to snap a picture if you need to. Ooh, yeah, we got time for, I think, one more. All right, let's do number 5, continuous and not continuous. Does this graph right here, the first one, go forever to the left and to the right? Does it go for, it goes goes this way forever, right? Does it go this way forever? Then it is non-continuous. When it is non-continuous, I want to see how far to the left does it go? Where does it start on the left? At 1. And does it stop anywhere on the right? No, goes on forever this way. So my domain is 1 to infinity. Gets a square bracket around the 1 because it's a filled in dot on my graph. If I can actually touch it, if I'm allowed to touch it or I can touch it, it gets a square bracket. If I'm not allowed to touch it, like with an open circle, or if I can't touch it, then it gets a parenthesis. Can you ever arrive at infinity? If you're allowed to touch it, then it gets a square bracket. So if it has a filled in dot there, or if it's part of my graph and I can touch it with my pencil, it gets a square bracket. If I'm not allowed to touch it, so like an open circle, or it's impossible to touch it, like with infinity, I can't ever get to infinity to touch it with my pencil, then it gets a parenthesis. For the range, domain goes with my x's. I'm looking left and right. Range, I'm looking at the y's. So I'm looking first at the bottom, because I want the smallest first, and then I look at the top. What's the lowest this graph ever goes? 2. What's the highest the graph ever goes? Infinity. Goes up forever. It's moving slowly, but it's still going up. So 2 to infinity. Square brackets and parentheses for the exact same reasons. Second one here, and then we'll finish up for today. We'll be done. Does this one go forever to the left and to the right? Yes. So this would be an example of a continuous function. If it is continuous, goes forever to the left and to the right, then my domain is negative infinity to positive infinity. Always. Then I want my range. Again, that goes with my y's. What's the lowest this graph ever goes? Positive or negative infinity if we're talking about the bottom? Negative infinity. What's the highest the graph ever goes? 1. Can you get up to the top of this parabola with your pencil and touch it? Yes. So would I put a parenthesis or a bracket? Bracket. All right. Bell's going to ring here in just a couple minutes. I think we got all the way through module 1. Is that correct? Oh, we still have a couple more. We got some more graphs. So we'll finish up those 2 problems and we'll do module 2 on Monday. And then we'll take questions off of modules 4 and 5 on Tuesday. Keep working on your cheat sheets over the weekend. Please make sure that you're taking the time to fill that in with any information that you want to have on the exam. That includes any and all formulas. I will not give you any formulas at all on the exam. Tuesday. End of the class period on Tuesday. I will collect your pink sheet from you, just so that there's no chance that anything happens to it between then and when I see you for your exam the next day. Give me just one moment, Julian.
I'm going to your